Find y prime for 3x to the fifth plus 2y to the fourth plus 2 equals 130 at the point 2, negative 2. In this situation, I'm going to find the derivative of this function implicitly. If you can write a function in an explicit form and find its derivative, that will work, but sometimes it's actually a little easier just using the implicit form. And implicit differentiation is pretty straightforward once you get used to it. What you do is go through your equation term by term, differentiating any variable x as you would normally, and when you differentiate any variable y, you multiply by dy dx just to complete the chain rule. So 3x to the fifth has a derivative of 15x to the fourth power. 2y to the fourth, we're treating this as an outer function. We differentiate our outer function, which would be 8y to the third, and then you complete the chain rule by multiplying by the derivative of the inner function. Well, the inner function is just y, so we put this marker dy dx indicating that later on we expect we will differentiate y with respect to x. So it just completes the chain rule. The derivative of any constant is just 0. So the derivative of 2 is 0 and the derivative of 130 is 0. So this is now just equal to 0. In order to work with this, I need to get dy dx by itself. So the first thing I will do is subtract that 15x to the fourth over to the other side of the equation. Next, to get dy dx alone, which is my objective, I'm going to divide both sides by 8y cubed. So negative 15x to the fourth over 8y cubed. And there is my derivative. It doesn't look like I can simplify any further. Now, in order to evaluate this derivative, notice that there is x and y pieces in my derivative. And that often happens when you have an implicit derivative. And that's okay, because you have both an x and a y value in the original point that you want to plug in. The notation that's often used is to just put a bar, which usually indicates to evaluate a function, and then just put the point after that. It's certainly not the only way of notating this, but it's one of many. So what that means is I need to put in a positive 2 for x and a negative 2 for y. So I end up with negative 15 times 2 to the fourth power. Well, 2 to the fourth power is 16. And then I have 8 times the quantity negative 2 to the third, which is negative 8. So right away, I can see that these negatives will cancel each other out. 8 will go into 16 2 times, and then this factor of 2 will go into this 8 4 times. So that leaves me 15 over 4. And that's going to be the slope of the curve at that particular point. So 15 fourths. And it's not always necessary to write an exact value, but it's always a good idea if you're uncertain. It's definitely more preferred over any approximation.